All right, so are you ready to dive deep? Because today we're looking at safety engineering.
Oh, yeah.
We found this real cool Q&A document. It's like Safety Engineering 101.
Nice.
It's from this safety pro who's been in the game forever, and it's amazing.
Awesome.
It made me think about all these things have you ever wondered what it takes to keep a chemical plant from
Exploding.
yeah, exploding, or how those safety features on machines actually work to keep us safe?
It's funny because safety engineering, you don't really notice it until something goes wrong.
Yeah.
But all those everyday safety things that we kind of just take for granted,
Right.
they're the result of a ton of planning and expertise.
Okay, so let's break this down, starting with the basics. What does a safety engineer actually do? Our document says it's designing safety programs, but what does that look like in real life?
So imagine this. A safety engineer, they're the one responsible for spotting and then dealing with potential hazards in any environment.
Okay.
It could be anything from doing these super detailed workplace inspections.
To analyzing data from past accidents to figure out why they happened in the first place.
So they're kind of like detectives, right? Piecing together clues to stop future accidents.
Yeah, exactly. And their work. It's all over the place. You'll find safety engineers on construction sites.
Making sure nothing falls down.
Exactly. Making sure the scaffolding's sturdy, and then in factories, making sure machines operate safely.
I bet that's super important.
Oh, yeah. And even in offices, believe it or not.
Offices, really.
Yeah, you'd be
I
surprised.
wouldn't think there'd be many hazards there.
Oh, there are even something like a badly designed workstation or a cluttered escape road. Those can be risks. It's all about finding those hazards before they become problems.
Okay. That makes sense. So speaking of hazards, how do safety engineers actually find them? Do they have some kind of hazard superpower or a sixth sense?
No, it's way more down to earth than that. Our source lays out this whole process for finding hazards, and it starts with really thorough inspections.
Yeah. They're trained to spot things that most people would miss, like improper chemical storage.
Oh, yeah.
Or faulty wiring.
So it's like the devil's in the details, right?
Absolutely. And it's not just looking around. They also analyze data.
Data.
Yeah, like accident reports and near misses.
Okay.
Looking for patterns and trends that point to underlying safety issues.
So using data to tell a story about what might be going wrong.
Exactly. And here's where it gets really cool. Our source material talks about how important employee input is.
Oh, that's interesting.
Yeah, safety engineers often rely on the people who work in that environment to spot potential hazards they might have missed.
Yeah, that makes sense. The people who are there every day probably have a different perspective.
Exactly. Our source even gives this example from a chemical plant.
Oh, wow.
An employee noticed this faint smell near a storage tank.
Okay.
Turns out there was a tiny leak that could have been a huge problem if it hadn't been reported.
Wow, a near miss.
Yeah.
That's a perfect example of how everyone has a role to play in safety.
Totally. But to do this kind of work, you need some serious skills and knowledge, right?
Yeah, what kind of certifications are we talking about here?
It's a really specialized field for sure. Our source lists a bunch of certifications like NEBOSH,
Okay.
OSHA 30, even ISO 4501 lead auditor.
Wow, I've never heard of some of those.
These certifications show that someone deeply understands safety regulations, risk assessment techniques, and hazard control strategies.
So it's not just about knowing the rules, it's about knowing how to use them in real life.
Exactly. And maybe even more importantly, it's about having those critical thinking skills to figure out hazards and come up with good solutions.
Makes sense,
Yeah.
but it doesn't end there, right? Safety regulations are always changing, so continuous learning is key for anyone in this field.
Yeah, you can't just use a safety manual from 10 years ago.
Definitely not.
Our source mentions things like going to conferences, reading industry publications, and taking more courses to stay up to date.
So they have to be lifelong learners.
Yeah, to stay ahead of the game.
Okay, so we've got our hazard hunters with their certifications and their thirst for knowledge. Now let's dive into one of the core concepts in safety engineering, the hierarchy of controls.
Ah, yes. This is the foundation for how safety pros think about minimizing risk.
Okay.
Imagine you're trying to stop someone from falling off a ladder. What's the best way to do that?
Well, the best solution would be to not need the ladder at all, right?
Exactly. That's the top level of the hierarchy elimination.
Eliminate the hazard.
But a lot of times you just can't get rid of the hazard completely.
Yeah, that makes sense.
Yeah.
So what do you do when you can't just get rid of the hazard? What are the next steps in this hierarchy?
So if you can't eliminate it, the next best thing is to substitute it with something less dangerous.
Okay.
With the latter, maybe you could use a safer, more stable platform instead.
Oh, I see. So elimination, then substitution, what comes after that?
Next, we've got engineering controls. These are physical changes to the workplace to reduce the hazard,
Okay.
like adding guardrails to the ladder to prevent falls.
So you're like building in safety features to minimize the risk.
Exactly. But sometimes engineering controls alone aren't enough.
Right.
That's where administrative controls come in.
Okay.
These are procedures and policies to reduce exposure to the hazard.
Like making training mandatory for anyone using the ladder.
Exactly, or having a buddy system so no one climbs alone.
Interesting.
But even with all these controls in place, there's still a chance something could go wrong.
Right.
That's why the last line of defense is personal protective equipment, or PPE.
So in our ladder example, that would be things like a hard hat and a safety harness.
PPE is designed to protect the person if something happens.
Oh, yeah.
But it's important to remember that it's the least effective control because it relies on people using it correctly all the time.
Right. It's the last line of defense.
Yeah,
This hierarchy is a really good way to picture those different layers of protection.
I agree.
But I'm curious, why isn't elimination always the answer, even if it seems like the most logical choice?
Well, sometimes getting rid of a hazard completely just isn't practical or even possible. Think about driving. You can't eliminate the risk of an accident completely,
Right.
but you can definitely minimize it by following traffic laws, wearing your seatbelt, and keeping your car in good shape.
I see your point. It's about finding that balance between safety and being realistic.
Exactly, and that's where the concept of risk comes in.
Okay.
Our source is very clear about the difference between a hazard, which is the potential for harm,
Got it.
and risk, which is how likely that harm is to actually happen.
So to stick with driving, the hazard is the possibility of a car accident. But the risk is affected by things like weather conditions, the driver's experience, even the type of car.
You get understanding this difference is so important for safety engineers
Why?
because they need to be able to assess how risky different hazards are
Oh, okay.
so they can prioritize their efforts and resources.
Makes sense. But how do they actually measure risk? Is it like a gut feeling, or is there more like systematic way?
There are actually specific tools for this, and one of the most common is the risk matrix.
Risk nature.
Imagine a grid
Okay.
where you plot the likelihood of a hazard happening on one axis and the severity of the consequences on the other.
So a hazard that's likely to happen and has really bad consequences would be in the top right corner, showing a high level of risk.
Exactly. And this lets safety engineers rank different risks visually
Okay.
and focus on the biggest threats.
So the risk matrix is kind of like a roadmap for prioritizing safety efforts.
That's a good way to put it.
But how does all of this play out in real-world scenarios? Our source is packed with examples of hazards and the controls used to mitigate them.
Yeah, one that comes to mind is the lockout-tagout procedure.
Okay.
It might sound simple, but it's super effective in preventing accidents during maintenance or repairs.
Can you remind me what lockout-tagout is again?
Sure, basically you completely de-energize a piece of equipment before anyone starts working on it.
Okay.
You lock the power source in the off position and attach a tag with your name and the date saying that the equipment shouldn't be turned back on.
So it's like a fail-safe to stop someone from accidentally turning it back on?
Exactly. This procedure has stopped so many injuries and even deaths.
Wow.
Our source actually talks about a case where a technician was working on a conveyor belt
Okay.
and it accidentally got turned back on.
Oh, no.
Thankfully, he was wearing a safety harness that was properly anchored,
Wow.
which stopped him from being pulled into the machinery.
That's a scary reminder of how important even those basic safety measures are.
I agree. And then there's machine guarding,
Okay.
which is another big part of safety engineering.
I'm picturing those safety guards you see on things like table saws
exactly.
and drill presses.
The goal is to physically block access to dangerous moving parts.
Makes sense.
And those guards, they're designed to be tough and reliable, often with interlocks that stop the machine from working if the guard is removed or messed with.
Like building a fence around the danger zone?
Yeah, that's a good way to put it. And this is a great example of how engineering controls can really lower risk.
I see that. But what about situations where those physical barriers aren't enough?
Yeah.
Our source also talks about some pretty intense scenarios like confined space entry.
Oh, yeah. Confined spaces like tanks, silos, or underground vaults, they have all these unique hazards.
Yeah.
Limited ventilation, hazardous atmospheres, even the risk of engulfment.
So it's not just about falling or getting caught in machinery. It's about the environment itself being dangerous.
Right. And that's why confined space entry requires so much planning and preparation.
Gotcha.
Our source really emphasizes pre-entry testing to check for hazardous gases, making sure there's enough ventilation, and having specialized rescue equipment ready, just in case.
It sounds like working in a confined space requires a whole different level of awareness.
It does. Even a small mistake can have terrible consequences.
Okay, so we've covered a lot in this deep dive.
Yeah.
But we've only scratched the surface of safety engineering. Our source mentions even more advanced concepts, like LRP, the bow tie method, and HAZOP studies.
These are specialized tools and techniques that safety engineers use to analyze complex systems, assess risk, and develop really strong safety programs.
Wow.
They're super important in industries where an accident could be catastrophic.
So like chemical plants, oil refineries, things like that.
Exactly, but we'll save those more advanced concepts for later in the deep dive.
Okay, so that's good.
For now, let's shift gears and talk about the human side of safety engineering.
Oh.
Because in the end, it's not just about rules and equipment, it's about people.
I'm really interested to learn more about that. How does the human element factor into safety engineering? So we were just talking about how safety engineering isn't all about, hard hats and regulations. It's about people.
Yeah.
And that brings us to the whole idea of safety culture.
Absolutely. You can have the best equipment and the most perfect procedures, but if people aren't really into safety, it just doesn't work.
Our source makes a big point about how strong safety culture. It's more than just following the rules.
Yeah, it's deeper than that.
It's about making an environment where everyone really cares about safety first.
Like it's the top priority.
Yeah. So in a really strong safety culture, people aren't just following the rules because they have to. They're following them because they believe in it.
Yeah, they believe that safety is important for themselves and the people they work with.
Exactly. So it's about creating this mindset where people are looking out for each other.
Yeah.
And they're not afraid to speak up if they see something that seems unsafe.
You got it. And that's where communication comes in big time.
Okay.
Our source talks about training as the foundation of a strong safety culture.
Right.
But it's not just about those first safety meetings when someone starts a new job.
It's about ongoing training and communication, right? Keeping safety top of mind.
Yeah, exactly. It's those regular refreshers, toolbox talks, updates on new procedures or hazards.
Okay.
And it's not just about lecturing people either. Right. Good safety training needs to be engaging and interactive.
I bet using real-life examples or case studies could make a difference. If people can relate the training to something real, they're more likely to remember it.
Oh, for sure. And you got to make sure the training is relevant to what people actually do on the job.
Yeah, a forklift operator needs different training than someone who works in an office.
Exactly. But even with the best training, people might forget stuff.
Yeah, or get complacent.
Yeah, that happens. How do you fight that? Visual reminders are good.
Okay.
Think posters, safety signs, even floor markings that remind people about key safety stuff.
I've seen those. They're like a constant nudge to be aware of hazards.
And then there's the power of storytelling.
Storytelling?
Yeah, sharing real stories of accidents or near misses.
Okay.
Especially ones that happen within the company can really hit home.
Yeah. It's one thing to hear about safety in general, but it's another to hear about a coworker who got hurt because they didn't follow the rules.
Exactly. It makes it real and personal, and people get motivated to be more careful.
That makes sense. But communication isn't just about giving information. It's also about listening to employees, right?
Yeah.
Getting your feedback and dealing with their concerns.
It's a two-way street. You got to create a dialogue where everyone feels okay about sharing their thoughts on safety.
Okay, so that open communication builds trust and a feeling of shared responsibility for safety.
Exactly.
We've talked about how communication is key for a strong safety culture. But what are some other signs of a workplace where safety is really thriving?
One of the biggest is leadership commitment.
Okay.
Safety can't be just a box to check.
Right.
It needs to be a core value that everyone from the CEO down to the supervisors is behind.
So leaders can't just say safety is important. They have to actually show it.
Yeah, they need to be seen participating in safety stuff, following the rules themselves, and recognizing people who prioritize safety.
Setting the example.
Yeah, setting the tone from the top and making it clear that safety is not optional.
And then there's the idea of empowering employees.
Right.
Giving them a voice in safety matters.
Yeah.
Involving them in finding hazards, encouraging them to be part of the solutions.
Instead of just telling people what to do, you make them feel like they're part of the solution.
Yeah, and when employees feel like their input matters, they'll probably be more engaged in safety.
And take ownership of their actions.
Which hopefully leads to better compliance with safety procedures.
For sure. And lastly, a strong safety culture needs accountability.
Yeah, okay.
Everyone has to be responsible for what they do.
Right.
From workers following procedures to supervisors enforcing them, and management providing the right resources and support.
So it's not just someone else's job, it's everyone's responsibility.
Exactly. And when you have all those pieces in place,
Okay.
strong leadership commitment, employee empowerment, clear accountability, that's when you have a foundation for a really strong safety culture.
This has been eye-opening.
Yeah.
I'm seeing how safety culture is so much more than just rules and regulations. It's about creating a shared mindset, a community where everyone's looking out for each other.
And that's what makes the difference between just following rules and really living a safety-first approach.
Okay, so we've covered a lot so far. Hazard identification, the hierarchy of controls, the importance of safety culture.
Yeah, we've been busy.
But there's still more to explore.
Oh, yeah.
Our source mentions all kinds of interesting stuff about specific areas like construction safety, industrial safety, even incident investigation.
Yeah.
Those sound like fascinating areas to dive into.
Yeah, they are.
Where should we start?
Yep.
Okay, so we've been talking about safety culture and how it impacts, everything from finding hazards to preventing accidents.
Yeah.
Now I'm kind of curious about how safety engineering works in specific industries.
Yeah, me too.
Our source talks about some really interesting examples in construction and industrial settings.
Oh, yeah, construction, that's a great place to start.
Okay.
It's so fast-paced and ever-changing, and there are just so many risks.
Right, like constantly moving.
Yeah, our source really emphasizes fall protection systems as a key area for safety engineers in construction.
Makes sense. Construction sites, they often mean working way up high. And falls are like a leading cause of workplace deaths.
Exactly. So a safety engineer who specializes in construction, they'd be super involved in designing and setting up fall protection systems that meet those really strict safety standards.
So things like guardrails, safety nets, personal fall arrest systems.
You got it.
But it's not just about having the equipment right. It's about making sure it's installed properly and that workers know how to use it.
Oh, absolutely. Training is like the most important part of any fall protection program.
Yeah.
Workers need to know what the equipment can and can't do, how to check it for damage, and how to use it safely in different situations.
And what about scaffolding? Those tall structures always seem kind of risky.
Yeah, scaffolding safety is another big worry in construction.
Okay.
Our source talks about how important regular inspections are to make sure the scaffolding is strong and put together correctly.
Right.
And they also highlight training workers on the safe way to put up takedown and work on scaffolding.
So many things to think about.
Yeah, lots of moving parts for sure.
And it's not just about the structure itself.
Nope. You gotta think about things like how much weight it can hold weather conditions, how close it is to power lines.
Wow. I bet a construction site is like a real-life puzzle for a safety engineer.
Oh, it definitely can be.
That's where something like a job safety analysis or JSA comes in handy.
Oh, yeah, the JSA.
Can you remind me what that is again?
Sure, it's this process where you break down a task into each little step.
Okay.
And then you figure out what hazards could pop up at each step.
So you're basically trying to predict what could go wrong before it does.
Yeah, exactly. And then you come up with ways to control those risks.
Okay.
It could be something as simple as making everyone wear safety glasses, or something more complex like setting up a lockout, tagout procedure.
So the JSA is like a proactive approach to safety, which fits with everything we've been talking about.
Yeah, for sure. And it's a useful tool for any industry, not just construction.
Okay, beyond construction then.
Right. Let's move on from the construction site and dive into industrial safety.
Okay.
Our source mentions this really interesting hazard combustible dust explosions.
Combustible dust explosions. I've never even thought about that as a hazard.
It's actually more common than you might think, especially in industries that work with fine particles like grain wood or certain metals.
Okay.
If enough of that dust builds up in the air, it can make the whole atmosphere explosive.
Wow.
And then a spark or a hot surface is all it takes to set it off.
So it's like the air itself becomes fuel.
Yeah, kind of. And preventing these explosions is a top priority for safety engineers in those industries.
So what do?
They look for places where dust might pile up. They put in dust collection systems.
Okay.
And they have strict rules about keeping things clean to keep dust levels low.
So it's about controlling the fuel source, getting rid of anything that could spark a fire, and keeping the workplace clean.
And just like in construction, training is super important.
Right.
Workers need to know about the dangers of combustible dust and the precautions to take to stop an explosion.
Okay, so we've got falling hazards in construction, combustible dust in some industries. What other common industrial hazards do safety engineers deal with?
Well, machine safety is a big one across many industries. We talked about machine guarding already.
Right, those physical barriers.
But there's so many safety rules and engineering controls to prevent injuries from things like rotating parts, pinch points, sharp edges.
It's all about keeping the worker and the hazard separate, right?
Yeah, as much as possible, and that might mean using interlocks, light curtains,
Okay.
or even pressure-sensitive mats that stop the machine if someone gets too close.
So many different ways to keep people safe.
And then you have processes like welding,
Okay.
which are risky because of the intense heat, sparks, and fumes.
Right. PPE must be so important for welders.
Absolutely. They need those special helmets with face shields, gloves, flame-resistant clothing to
Right.
protect them from burns, sparks, and UV radiation.
So much to consider.
And they also need proper ventilation to get rid of those dangerous welding fumes.
So it's not just about protecting them from the task itself. It's about protecting them from the byproducts of the task, too.
Exactly. And in many industrial settings, you also have to think about chemical hazards.
Right. Our source mentioned how important those safety data sheets are
Oh yeah, the SDS.
for every chemical used in a facility.
Yeah, the SDS gives you all the info about the chemicals hazards, safe handling procedures, first aid measures, emergency response protocols.
Like a safety manual for that specific chemical.
Exactly.
And good labeling is key, too, right?
Oh yeah, so workers know exactly what they're dealing with.
Right.
Clear labels are crucial to stop people from accidentally mixing the wrong chemicals
Okay.
or using the wrong chemical for a job.
So many potential problems.
And then there's training. Workers need to know how to handle chemicals safely, how to use PPE, and what to do if there's a spill.
It sounds like safety engineers have a ton of responsibility in these industrial settings.
Yeah, they do. They play a vital role in keeping workers safe from so many hazards.
But even with the best safety programs, accidents can still happen.
That's true.
And that's where a safety engineer's investigative skills come in, right?
Exactly. When something happens, a safety engineer often becomes an investigator.
Right?
They gather evidence, talk to witnesses, and analyze data to figure out why the accident happened.
So it's not just about what happened, but why it happened. So you can stop it from happening again.
Exactly. And they use all sorts of tools and techniques,
Yeah.
like root cause analysis, which is about digging deeper
Right.
to find those underlying factors that contributed to the accident.
I remember our source talked about a technique called the 5 whys.
Oh, yeah.
Can you explain that?
It's actually pretty simple, but it works really well. You start by asking why something happened,
Okay.
and then you take the answer to that and ask why again.
Uh-huh.
You do this 5 times each time, going a little deeper into the causes.
Like peeling back the layers of an onion.
Yeah, that's a great way to put it. And by figuring out the root cause, you can come up with better solutions to prevent it from happening again.
This whole process of incident investigation, it really shows how important analytical and problem-solving skills are for safety engineers.
Oh, for sure. They need to be able to think critically, analyze data, and draw conclusions based on evidence.
So we've covered a lot of ground in this deep dive. From identifying hazards to safety culture to the specific skills needed in different industries.
Yeah, we've gone from the basics to some pretty complex stuff.
And one big theme keeps coming up, the idea of continuous improvement.
That's so important.
Our source is very clear that safety is never really done. It's an ongoing process of evaluating, adapting, and trying to get better.
Exactly. A strong safety program isn't something you just set and forget.
Right.
It's always changing. As new technologies come out, regulations change, and we learn more about how people behave.
So as we wrap up this deep dive into safety engineering, what's the key takeaway for our listeners?
I think the most important message is that safety is everyone's responsibility. It doesn't matter what your job is, whether you're the CEO, a manager, or a frontline worker. You have a role to play in making and keeping a safe workplace.
And that starts with awareness. Pay attention to what's around you, spot potential hazards, and speak up if something seems off.
Don't be afraid to ask questions or suggest improvements.
Yeah, even small actions can make a big difference when it comes to safety.
Totally.
So next time you see a safety procedure or a warning sign, take a second to think about all the work that went into creating that safeguard.
Because behind every safety rule and every piece of protective gear, there's a whole story of people working hard to keep others from getting hurt.
This deep dive has given me a whole new appreciation for the things that keep us safe every day.
I'm glad to hear that. And hopefully it's made you curious to learn more about this important field.
So until next time, stay curious, stay engaged, and most importantly, stay safe.